All right. Let's see if I can do this. Okay, so I'm just going to introduce, I'll talk first about the content of the course, and then I'll talk about, you know, the details, the operational details of how this is going to do the homework, how we're going to be graded, the peer grading that I have in store for you. Okay, so first, I think the content is more important than those details. So this is a course called Analysis of Programming Languages. And it's sometimes some students confuse it with program analysis, which is a very narrow kind of technique in software engineering for analyzing programs. It can be static or dynamic analysis and things like that. All sorts of interesting techniques around that. And we do have a course, I think, on, or at least there's one course planned on program analysis, and that this is not it. Here what we're going to analyze is the programming languages themselves and the way that the programming languages have emerged, and the kinds of families of interesting ideas that have emerged over the years. And the reason for that is that the reason for having this course is that we, you know, in computer science and software engineering, ultimately we end up writing code in somewhere. we write a lot of code, and yes, the ideas and the algorithms are super interesting and whatnot, but the code itself, it turns out, it's also very interesting, and it can be either a mess or it can be a nice body of code. And I don't know, some of you have already worked in companies. I think you will sympathize with what I'm saying. So, you know, all of these ideas, incredible ideas out there that are, you know, running the world through software are some, you know, at the bottom there is code, and code that is written by people, and code that is written by people for computers to execute, but that is almost incidental. It's more important that it's written for other people to understand, and even ourselves sometimes later when we write the code, and then sometimes 6 months later we come to the code like, who wrote this piece of crap? So the code is important, and it's the way that we write it, the way that we organize it, the way that we divide things into ideas and put those ideas back together is super important to for the health of a software system. So those ideas have been sort of embedded in many ways in programming languages. So different programming languages over the years have had interesting ideas about how to divide things and put them back together. And there's sort of, you know, the families of programming languages that you probably all know about, you know, imperative languages, object-oriented languages, functional languages, logic languages, all of that good stuff. But those are very broad strokes, right? At a finer granularity, there's a bunch of interesting design ideas that may or may not have been frozen in some construct of some programming language. Some of them have found their way to some constructs of programming languages. Some of them haven't, but people use it considerably. And so this is the course that you're going to learn here is all about programming, okay? And it's very hacky in many ways. We're going to dive in on how we write programs and the kinds of division of labor that we have among our, you know, our functions, our modules, our objects, and things like that. Now we put them back together, and what, you know, kind of the trade-offs that certain ideas have with respect to others. So I have this slide over here that's been blabbing over, but really, when we go into a software system, the code is sort of the bottom line, and there's people around the code in many ways, and people communicate through the code, right? It's you know, in many times when the code is very well written and is very clear, you can just avoid a lot of confusion and a lot of meetings. You can avoid a lot of meetings. That's a good thing. And other times when the code is very confusing, then it's prone for bugs. It's a lot of confusion between even teams who write who are writing different modules of the software. So it can be actually quite a problem from a social perspective. So it is important. I think my impression that in computer science we give way too much importance to the fancy algorithms and systems design and stuff like that, and we don't give as much importance to actually how we write the code. And it turns out that it's actually pretty important. It has a lot of consequences when you have a body of code that has been poorly written. So programming languages are a universe of design ideas. That's the interesting thing. And if you pay attention, some of those design ideas many times pop out into systems design. A typical example of this is MapReduce. MapReduce, many of you have heard about because it was made famous by Google. It's a framework for massively parallel data processing. But some of the ideas from MapReduce, which is a sort of at the data center level in the Google world, came from Lisp. Okay, 1966. That's when these words were kind of given some meaning in the context of Lisp. What was map and what was reduce? It was something that there were functions in the Lisp library that did pretty much the same things that you see now the computers in the data centers do. But they were done at a sort of a smaller scale, at the programming language scale. Things about state, how to deal with state, is something that programming languages have been struggling and inventing for a very long time. And some of those ideas make it to systems design, right? So, for example, all these ideas of the little lambdas, right? The lambdas in AWS, the lambda infrastructure, or things like that or serverless. It's called serverless architectures. Are basically systems level versions of functional programming, right? So it's important that we kind of understand. There's some really interesting things at the design level that you find at many levels, from the small micro programs to systems design. And it's the same ideas. It's the same ideas. That's the important thing. So I want us to stop, worrying about algorithms, and let's focus on those design ideas. And let me tell you what those design ideas are about. They're actually even more powerful than just systems design. They're also at the social organization design. They're also important there. Because what these ideas are about is, if you have a big system, how do you go about to break it down into smaller parts and to put those parts together again? Okay, that's the core of the problem that we're focusing here. You have a you need to write a big thing, right? You need to design a big thing. We know that we need to break it down in smaller things, right? We need to break that big thing in smaller things. And then we have to have those smaller things talk to each other, somehow interact with each other. And there's lots of ways of doing this thing. There's ways that you centralize the state in one place. There's ways that you distribute the state in one place. There's ways that you don't keep state anywhere. You kind of keep the state on the back end. There's lots of things. And all of those ideas are ideas that apply every time that you have the same problem, which is you have a big thing and you need to divide it, and now you need to put the pieces back together. And that happens, social organizations, systems design, you name it. So these ideas are really interesting. And that's what we are going to focus here. So as I said, what I call programming styles. My definition of programming styles is a little I use the word style to denote basically a set of constraints. Okay, so if you give yourself a set of constraints, you end up with creating something in a certain style, right? For example, this is in general. This is not just programming. So, for example, if you give yourself a constraint, if you're doing painting, for example, and you give yourself a constraint that there should be no curves. There's no curves. Okay, you cannot do curves. You end up with paintings that all have a certain style because they all obey that constraint. Okay, or if you would say that there's no lines or curves or anything, everything that you do is little dots. So you just have little dots. So we end up with something like Impressionism, right? Style of Impressionists. So it's the constraints is the things that actually are underneath the what we call styles, right? But what we call styles really emerge from us applying a set of constraints. Okay. And so once we have those styles, some of those styles have become important enough, and that language designers have decided to adopt them at the language level. So, for example, objects. Okay, the object-oriented concept, the concept of objects, is something that you can have without having an object-oriented language, without having it at the language. But it was important enough at the time that some language designers decided to enforce that concept at the language level, right? So but there are other things, other styles that are interesting too, but never really made it to a programming language. But we'll be talking a lot about that. So we'll be using a mixture of styles. Some of them have made it to some programming languages, others haven't, but we'll cover some of them. So it's important to know these foundational concepts independent of the languages, because sometimes they are very handy, even if you're programming in some programming language that doesn't have that particular idea, but you think that that's a good idea, then you should just make a little layer, a little framework that gives you that kind of style on top of the language. So constraints, as I said, is principal decisions. It's basically things that you must do and then things that you must not do, right? That's basically, once you decide, this is true in general, not just for programming. If you're writing a book or writing a story or whatever, a lot of authors, a lot of creative people do this. They basically say, okay, I'm going to not do this ever in my work, right? Or I'm going to always do this, or have this kind of thing happen in every chapter of my book, or something like that. These are the kind of decisions that are sort of the skeleton upon which the creation kind of evolves. Okay, so that's how I'm using the word style. So it emerges from a set of constraints and principal decisions. Okay, so programming languages of course have a long history. They were invented in the 40s through the 90s. A lot of these concepts, there was a kind of an explosion of interesting ideas in those 30 years between the 40s and the 70s. There were some interesting ideas in the 80s. There were some in the 90s, a little bit less. The explosion has kind of slowed down. I mean, this was because, obviously not everything has to be invented, right? So when we started to program computers, there were no programming languages, and everything had to be invented. So it was a very creative time throughout, the first 30 years, and then things obviously slow down a little bit more. But people keep reinventing things when the context is right. And so it's important. One thing that I'm going to cover here in this course is the history of programming languages, and a little bit of history of computers and computer science too, because they are intertwined in many ways. So I will always go to the sources of these ideas, where they were invented and in what context they were invented. So as I said, this course sits somewhere in the middle between, application design and compilers and interpreters. So it's programming language design or framework design. In fact, you will see at the end of the course, the way that I see this and that I have seen this is that there is a difference. You all know how to program. Okay, you all know how to program. You've written programs. That's not a big deal. But there are two kinds of programmers, and there's two kinds of programs. There's the application code, which is code that is written for end users to use. And then there's library and framework code, which is code that is written for other programmers to use. And that's a whole other parade, okay? It's a whole other parade. It's like almost nothing in common. I mean, you're right, of course, right, the thing, but the things are different because for application, when you're writing an application code, you're focusing on end user experience, and end user experience has absolutely nothing to do with code, right? What they see is pictures on the screen or buttons on the whatever, and that is sort of the main concern, is that the UI is good UI, or that the program is correct, it does the right thing for the user, and so the code is, as long as it works, whatever, right? But when you're writing a library or a framework that is to be used by other programmers, then it's different, because your UI, the interface is code, right? And that interface needs to have the same properties that you would do a user interface, right? Which needs to be intuitive and good and powerful and natural, but it's code, right? And that's, it requires a different level of expertise and a different level of skill to be able to write a good framework, okay, or good library that is really powerful and simple to use and all that stuff. So in many ways, the way that I see this, the purpose of this course here is to kind of level you up from just writing programs that nobody will ever use to kind of, or that they will use but they won't build upon, to level you up to being a sort of a framework and library writer, to think about the things that you need to worry when you are writing code for other programmers, right? What kinds of interfaces do you provide? And how do you organize your thoughts? And how do you divide things? And how do you present the concepts that you are working with, right? That's the purpose of this course, the kind of a practical purpose of this course. There are lots of different programming languages, lots of them. There's a few very popular, and then there's a very long tail of not so popular, but very used programming languages. And if you go out and work in the industry, your chances of encountering some domain-specific language or some language that has been written for some specific purpose are very high. So I want you to appreciate the history, diversity of ideas, be prepared for all of these new languages, see beyond the hypes. There's a lot of hypes in our profession. Learn some important facts about the existing systems and techniques, and basically learn and think critically about some of these design trade-offs. I am going to be a little bit sort of agnostic with respect to how good or how bad something is. I tend to just present to you and just tell you what the properties are, because I think that how good or how bad it is, it depends on a lot of context. Okay, there's many things sometimes that we tend to judge very quickly because we judge based on our limited experience, but sometimes the context justifies certain things that in other contexts we will think it would be a bad idea. Okay, so level up your programming skills by several notches. So code, as I said, code for your peers. So you're moving from application programmer to a library and framework programmer. That's sort of the kind of practical consequence of what I'm saying here. And then the more academic and scholarly goal is the part of the history of these ideas and where they came from and how they came to be. Okay. All right, so this is my little presentation. Does anybody have any questions about this? This is what you're going to do for the next 10 weeks.
I guess I have a question. Are all the assignments individual, or are there some where we're like working together in a team?
That's okay. So let's go to those details. Let's go how I operationalize this. So let me share my screen again. We go here to Canvas. Okay, so hold on. Let me make my Zoom window a little bigger so I can see more of you. All right, so here's this course is a little unusual and very different. It's sort of an endurance kind of test rather than a sprint. So there are no projects or stuff as such. There's weekly exercises. So these are, you know, like, I don't know how many of you play an instrument like guitar or piano or violin or something like that. I'm sure many of you do. So for whenever you play an instrument, there's always those technical exercises that you do, right? For, I don't know, dexterity of the fingers or something like that, your vocal cords or something like that. There's exercises that are not the music, but they are just exercises that we do to get our body ready for the instrument. So this is how I see this. These are exercises, they're not the music, they're super small, okay? But they focus on one thing, okay? One of these styles, that's it, okay? And so, because they are exercises, they are designed for you to work alone, okay? It's your little exercise, okay? It's the piano scales or whatever other thing you do for other instruments. So there's no point in having sort of a group thing. You can discuss it. You should discuss it with each other. That's fine. You can do it in Piazza. You can do it on Slack. But when you type it down, just try to do it yourself, because it really is kind of the flexibility of your thoughts, of your ideas, how it works. Okay. So here's how it's going to be. There's going to be a set of exercises every week, a different styles every week, and everybody turns their assignments. Yeah. Now I'll tell you another interesting thing is that it's always going to be the same program. So we start with one program, which is a program that you probably already written somewhere in your life. It's a very simple program, not complicated. And then we do it, and we do it again, and we do it, 20 times in different ways. Okay? There's, I don't know how many, this is based on my book, by the way. Do I have a link to the book? So did I forget the link to the book here? No, there it is. Okay, so the book, this is, I think you need to get this book, and you need to get the second edition, because I'm going to cover a new part of the second edition that was not in the first edition, and it's the kind of the hype part for neural networks. I'm going to cover neural networks from a programming perspective. Okay, I had a lot of fun kind of analyzing neural networks from a programming perspective. So please get the book. And the book is organized, again, each chapter is a style. And so what we're going to do is go through the book. I will explain here in the lectures, the history, the context, all of that stuff. And then there's some exercises that you do. You turn it in, and then because there's 47 students and just one reader, we're going to do something that I actually did last quarter, and it worked pretty well, which was peer reviews. So I don't know how many of you have done peer reviews on Canvas. Yes, no, maybe, no. Okay, I think it worked well. It's a little weird at the beginning, but then it worked. I think it worked really well. So the ways we're going to do is that you're going to have to code these little exercises in REPL, which is this online, development environment, and then you leave your code there, and then what you submit is URL for your what they call those things. They call it workspaces or some. I forget what they call it. You can create such a workspace or whatever. So what you turn in is URL, it's shareable URL. You can share that URL. Other people can go and check what you did and run your program. Okay. So you turn that URL in, and then one day after the assignment is due, so all assignments are due on Sunday nights, okay, at midnight. And so on Monday night, I set up Canvas so that it automatically assigns randomly 3 of you to each. So each assignment is going to have 3 reviewers, and so each of you is going to do 3 reviews of 3 different random people. Okay, so there's a rubric that I have there. So basically, you just follow almost always the same rubric. And you just basically check if it was turned in on time, if it does the right thing, and then you have to comment on the style. Let me just show you a little bit. So if I go here in assignments, here for example, week 1 is a little different. Let me go to week 2. Oh, I don't have week 2. Crap. Okay. Sorry. So I still don't have haven't released it. So week 1, week 1 is starting next week. You can already do it if you want. It's only due the next Sunday, not this one. And this is just for you to know what the program is about. Okay, it's called term frequency. Okay, everybody knows term frequency. You have a file. You write the program that reads the file, splits the words. It normalizes the characters or whatever to lowercase, splits the words, gets rid of small words, and then counts the words and spits out the 25 most frequently occurring words. Okay, that is the program that you're going to write over and over and over again. So this first exercise for week 1 is just so you can write it however you want, in whatever programming language you want, however you want, doesn't matter. Just make it work. For week 1 is just make it work. And then and also so that you get familiar with REPL and how you should set it up. And so there's a rubric here that then the other students are going to check your environment on REPL, and so check that there are no errors, check that that compiles or whatever, and then check that it produces the right result, the exact right result. Okay, that's the rubric for assignment 1. For assignment 2, I can show you. I haven't released it yet, but I can show you here. But starting on week 2, then the rubric is slightly different. And basically, this is not the exercises. I may change. Okay, I changed this, so I haven't released it because I haven't really decided which exercise you're going to do. But so the criteria for the rest of the quarter is whether it's on time, whether it produces the correct behavior, and whether it honors the constraints and requirements of each of the styles. Okay, so I hope I will make it clear that you should write some comments. Okay, you should give a review to the program. Just notice certain things. Whatever. Maybe you shouldn't have called that function there, or oh, this is really nice. Yours is much shorter than mine, much more concise. So, some comments that are genuine and that shows that you're actually writing a review for that program. Okay, so there is a reader here, and the role of the reader is to then go after you. After your peer reviews, the reader goes and just checks everything, basically, and grades and gives you the score. So you are also asked to give a score or suggest a score. You have places there to give your own score, okay? But then the binding score is the one that the reader gives, okay? Because there's probably going to be, different scores given by the different students. Okay, questions about this?
I have a question. Why any language other than Python?
Because the book is all written in Python.
Okay.
So
in Python can be written in Python?
So let me show you. The book, which is also, there's a GitHub repo associated with the code in the book. And the GitHub, you have all the code of the book is in here. Okay? It's all here. And all of this has Python. Some of them actually have more than Python. And so in those cases, I also ask that you don't do in that particular programming, because at some point people were sending me different versions of programs, of these programs written in other languages. And for a time, I was accepting those pull requests. And then I started saying, hey, please don't do that because I'm using this in my classes. And then, the students don't have anything to do. So I stopped doing that. But there's some here that still have those other versions in other different programming languages. But so everything in here is pretty much, Python. Now this one has Scala too, see? So that's what I was talking about. So, so you can do any programming language except Python, and the other ones that are also here in certain styles.
Professor, I have one question. So regarding to the peer, do we have one peer for the whole quarter, or we have a peer review our work for different? We have different peer for every week. I
set it up on Canvas so that it's random every week.
Okay.
So every week, I'm not involved in that assignment. Canvas just does whatever it does. It's random. Now, so one little detail that I actually mentioned that in the exercise for week 1. Let me go that to and put the spotlight on that. So we're going to use REPL, and REPL you can sign up, for example, with a GitHub account or whatever. You can create an account in REPL. If you prefer to yourself be anonymous, if you don't want the other peers to know who you are, then make sure that you create some REPL accounts with some random name that is not your name. If you don't care, I don't care either. It's whatever you want. If you want to be anonymous, if you don't want your colleagues, your peers to know who you are, because what happens is that REPL discloses if I go here and I sign up, did I sign up? Yeah, I did sign up with mine. So you see here that I'm Krista, right? And if I share my REPLs, like if I go here and I share a REPL, this one or whatever, Lazy River, you see that URL has Krista in it, right? Mm-hmm. And this URL is the thing that you submit. So if you don't want that, then make sure that your account name that you sign up for REPL does not have your name. But it's not, this is just, I'm just warning you. If you want to be anonymous, you have to do that extra little thing. If you don't care, I don't care either. And by the way, since I'm here, this is how I would like you to organize your REPL environment. So I would like you to have folders for every week, okay? There will be not 7, but 9 folders. And then put there is a text file that we use for all the exercises. That's the book Pride and Prejudice, okay? And that's like the one that's like the test case, the input test for all these exercises. And also there's a list of stop words. So these are words that you will eliminate before you count them. So there's these 2 files. And you should put these 2 files sort of on the top level because they're going to be all reused every week. But then you go every week and you do, here's my, this is in C++, these are in Java. So then you put here your programs for that particular week, okay? And I have more instructions for what other things here. Here, where do you go? Here, okay. Right, so, yes, right. Any more questions about this? Okay, so will do. So basically, here's how it goes. There's a little interleaving of your assignments every week. So your exercises are due on Sunday nights. Then I release the peer reviews on Monday nights, and then you are supposed to turn your reviews in by, let's see if I remember and I don't say anything stupid. Let me see. So by October 15 is what? Okay, when's October? What day is October 15? Is it a Thursday? Let me see. Yeah, it's a Thursday, right? So every week you are supposed to turn in your reviews on Thursday. So the peers are released on Monday at midnight. The midnight between Monday and Tuesday. And then you're supposed to turn in your reviews by Thursday at midnight. Okay, so you have just a couple of days to do the reviews. There are the things in here that in other years I had made sort of mandatory, but because this is a weird world and I'm asking you to do the peer reviews, this year I'm not making mandatory, but I highly encourage you to read some of these papers, and I will highlight some of these papers every week. These are the collection of historical papers that are underlying this or other concepts. Okay, and some of them are really interesting. So I will try to remember to highlight it. You don't have to read it, but some of you might think this is interesting. Okay, what other thing? Right, there's no exam, no midterm, no quizzes. Your entire grade is just based on your exercises and the peer reviews. So for every week there's 80 points for the exercises and then 20 points for the review. And I am trying to remember what I did for week 1. Okay, week 1, yeah, that's right. So basically, it kind of shifted by 1 week. So you have 80 points on week 1, and then you'll get your other 20 points for week 1 on the next week when you do the reviews for your peers. Right. So the last week, the week 10, there will not be exercise to turn it in. There will only be peer reviews on week 10. Okay. And so. And basically, a final grade follows this table. There's sort of a leaderboard here. I will not have leaderboards, but basically, these are the levels that you need to reach to get to the letter grade. Okay, so basically, an A+ means that you have to have like perfect score every time. Okay, but you know, sometimes depending on how the class is doing, I throw extra points here and there. Extra credit here and there. Okay. Let me stop sharing. Let me see. Oh, what? Oh. Okay. So let me see. 31 people. There's 47 students signed up. I don't know where the others are, but hopefully they will watch this lecture because it's being recorded. So if you don't have any more questions, oh, okay. Before you go, there's a you know, how to reach me. Okay, that is important. And how so I am available on office hours, Tuesdays and Thursdays, 9:30 to 11 a.m. And I will. You guys are not on Slack, on the Slack channel, so I will start Zoom meeting and I'll wait for somebody to show up. Okay. You can also try to Slack me, but I am in the informatics Slack. Many of you are not informatics students, so you may not be there. So, but I tend to be available on, sort of this is the time that I give to students. Okay? If you want to reach me preferably during this time and synchronously. I tend to be terrible about email. Okay, so don't take it personally if I don't reply to your emails, because I don't reply to emails in general unless I have to. So I'm a lot more responsive on Slack and in kind of face-to-face. And then there's also a Piazza space that I created for this course. So if you have, as you are working on the exercises, if you have, questions or want to check something or other, just go here and post something on the corresponding week, homework one and whatever. Okay, and I will try to monitor this, but the reader will definitely also monitor this. Okay, and then you can feel free to answer each other's questions too, anything you know. Okay, what else? So there's the Zoom part of Canvas here where you can see all the meetings, and then I think that you can see the recordings here. There will probably be, what? Why is all these files in here? Okay, weird. There's a lot of recordings already, no idea why. But there will be, I guess the recordings will be there for the classes if you don't make it to the real thing. Okay, well, I will stop the class here today. Let me just remind that today is week 0, so you don't have anything due on this Sunday. The deadline, the first deadline is next Sunday. There's a little assignment left, which is this course policies. I want everybody to kind of read these policies and sign them up, and just like late homework and stuff like that. And just turn it in, scan it, and I'll take a picture and turn it in. But other than that, it's not even due until next week anyway. So you can start already working, or you can wait until next week when I talk about the beginnings of programming. Okay, it's gonna be fun. I'll see you guys next Tuesday.